So I've just opened up my Deform by Surface Start scene. This is just a basic scene with a sphere and a grid set up, and there's no ice trees currently on either of these objects. So we're going to start by going ahead and creating a simple deformer to get the idea of how this works, and then start adding more and more features in as we go through step by step. So we're going to start with just a push and have a look at that on this object, and then we're going to put a raycast on next. Creating the ice tree, stand ice tree, first of all, we have the ice tree node, and then we want to actually get the point position. By typing in point, you can see there's a get point position. There's also a set point position. We get both of those. We'll put the set point position into the port 1 and the object disappears. Put the get point position and the object comes back. We want to get point normal as well, and there's also a get point normal node. We want the add node. I'm just using a search here very quickly to get these nodes in without searching through multiple categories. And we'll just put these all together now. So we get the point normal, point position, and we'll add in to the set point position. And you see the object got larger. So next we need to control the size of the push. Use that by multiply by scalar. So I just start typing multiply in. We say multiply by scalar. Now I want to connect it between these lines. I can just drag again on top of those lines and it'll hook it in between. If you missed it in that case, just do it and you'll look at the line and the line should change color, and then it should hook between the two. And then we can adjust the scalar value to see how much it pushes by. So that's a push deformer, and that's fairly straightforward. And you can see again the 5 nodes, the point normal, multiplying that by scalar, point position, we add these nodes together and reset the point position. We can go ahead and make the next node that will allow us to actually deform the object up and down when it hits the ground. That's going to use a raycast. So I type raycast and we see raycast comes in. Now we have our location and the hit. We also need geometry, position, direction, and there's cutoff distance as well. Let's look at some of these values. If you really want to understand this, you can always click on the question mark to explain each of the nodes in the help. I know first of all I want geometry. That's going to be geometry it hits, and that's going to be this grid. If I select the grid, hit F3, open up a mini explorer, and I can just drag and drop it into the scene or into the ice tree, and then we can hook that into geometry. Next we need position. We have a point position here. It's good to reuse nodes whenever you can. So I'll just take the point position from here and hook it in to there. So now we have the point position and the value. Great. So now we have location. We need to set the point position to location. Now if I get another set point position, I can hit Control C, Control V. I'll try to hook the location into point position. It won't let me. It gives me an error message or a type mismatch saying we have a 3D vector output, but it wants a point input. So how do we get that? Well, we need to change these nodes around. We can do that by getting a get data. So take a get data. Location is a special type of data type. It allows you to actually change. So you can take the location into the source of the get data and then pull out different information from that. If I go to Explorer, we can see now we can get any of this information at that location. So we can go here, point position. Now we can hook the value. There's now yellow to yellow, vector to vector. and then we can hook that into the execute. Now if we unhook this one for a moment and hook this one into port 1 and we move the object up and down, we don't see anything happening right now. If we look underneath, the object's going straight through. That's happening because right now we haven't specified our direction. We can specify the value y to 1, and then when we bring it down, it's going to hit. And we can see how the object is actually squashing as it hits the ground. Now if we try to use both effects together, we could have both the push, you can see the push is working there, and the raycast together, but that's not really the effect I want. I really want this to adjust over distance, so it's only pushing at a certain point over distance. And that's where things get a little bit more complicated, and we're going to work on that in the next video.